On October 13, 2023, a Falcon Heavy lifted off from the same launch pad that once carried Apollo 11 to the Moon. The payload was a spacecraft named Psyche, aimed at an object NASA has quietly described as one of the strangest destinations in the entire solar system. The press release called it the beginning of asteroid mining. The headlines called it a $1 trillion comet. Both were wrong. Psyche is not a comet. It is a metal-rich asteroid, and the number you saw everywhere was not a valuation. It was a physics joke. The probe will not land, will not drill, will not bring anything home. It will arrive in August 2029, orbit for 2 years, and photograph a rock that may not even be what we were told it is. Everything else is pure marketing. And once you understand the math, the marketing starts to feel like a warning. Let me pause for a moment before I go any further, because I want you here for this. Tell me where you are watching from tonight and be honest with yourself for a second. When you first saw the phrase asteroid worth more than Earth, did you actually believe someone was going to mine it in your lifetime? Because the woman who first wrote that number, the planetary scientist Lindy Elkins Tanton, has spent the better part of a decade trying to walk it back. She wrote it as a thought experiment, a rhetorical device, a way to explain to a general audience why studying this particular object matters. She did not write it as a business plan. But the press cycle heard the number, ignored the footnote, and ran with it. $10 quintillion. Enough, in theory, to give every single person on Earth over $1 billion each. Enough to shatter the entire global economy on delivery. Enough to make every mining company on the planet obsolete overnight. It was clean, it was shareable, and it was completely disconnected from what the mission was actually designed to do. The mission was designed to look, not to touch, not to retrieve, not to enrich, just to look. Read that carefully. Every article you saw promising a new age of asteroid mining was describing a spacecraft that has no mining equipment on board. No drill, no collection arm, no return capsule, no cargo bay, nothing. And already, before the spacecraft even reaches its target, the newest ground-based data is suggesting the object we are flying 6 years to photograph may not be what any of the original press releases assumed. The thesis of everything that follows is simple. The catch is not the price tag. The catch is that the price tag is the least dishonest part of the story. And once you understand what Psyche actually is, you will understand why every serious engineer who has looked closely at this mission is quietly terrified of the follow-up questions.
So let's start with the version of this story you were probably told, because that version deserves to be read one more time, carefully, out loud, with the polish taken off. NASA's Discovery program approved the Psyche mission in 2017 as a relatively modest scientific probe. Not a flagship, not a moonlander, a focused, targeted, single-purpose spacecraft. The plan was to launch in 2022, arrive in 2026, and study a metal-rich asteroid roughly 226 kilometers across, orbiting the Sun in the outer asteroid belt. The scientific hypothesis was elegant. If this object really is the exposed iron core of a protoplanet, a small world that never finished forming, then studying it could give us the first direct look at the kind of iron heart that hides at the center of Earth itself. We cannot drill to our own core. We can barely image it. But maybe, a few 100 million kilometers away, there was a piece of an ancient core sitting exposed, waiting to be studied. That is a beautiful mission. That is a mission worth funding. That is a mission worth flying. And that is the mission NASA is actually running. The trouble started when the story left the science building and hit the newsroom. The 2022 launch slipped to 2023 because JPL's own independent review board found the flight software was not ready. That is a rare admission for the agency to make in public. and it should have been the first flag that the ground under this mission was less stable than the coverage implied. Then quietly, over the last few years, newer observations began to erode the core hypothesis itself. The story you were told is the story of a treasure. The story that is actually unfolding is the story of a question. And the question is starting to have uncomfortable answers. The public has been emotionally invested in a payoff the scientists never promised. And here is what most people never notice about the way this mission was covered. Almost every article treated the treasure interpretation as the default, and the science-only interpretation as the boring footnote. The scientific paper is careful. The tweet is loud. The tweet wins. That is not a conspiracy. It is a media pattern. And this mission is a nearly perfect case study in it. So if the gold isn't guaranteed, what exactly are we flying 6 years across the solar system to look at? The answer is stranger than the headline. And it's where the real problems start. To understand why, you need to understand how the spacecraft actually gets there, because the physics is already bleeding before the target is even in view. Psyche orbits the Sun at an average distance of about 3 astronomical units, roughly 450 million kilometers from Earth at closest approach, and over 600 million at worst. The spacecraft cannot fly straight to it. It carries 4 Hall-effect thrusters, ion engines that ionize xenon gas and accelerate it out the back with an electric field. The total thrust from all 4 thrusters combined is roughly equivalent to the weight of 3/4 resting in your palm. That is not a metaphor. That is the actual force. This is not a rocket in the way you think of a rocket. This is a whisper. A continuous patient shove that accelerates the spacecraft by fractions of a millimeter per second, day after day, month after month, for years. To make the trip in a reasonable time frame, Psyche will swing past Mars in May 2026 for a gravity assist, borrowing kinetic energy from a planet that has no idea it is being used, and then spiral outward for 3 more years before arrival. The total flight path is about 2.4 billion kilometers. That is more than 60 laps around the Earth's equator, in a single voyage, at a whisper. The probe will travel for the length of an entire US presidential term without arriving. Think about that for a second. The engineers who launched it will not be the same engineers who receive its first orbital photos. Careers will end. People will retire. Some will die. And the spacecraft will still be coasting. There is a precedent for this, and the precedent is instructive. The Dawn mission, launched in 2007, is the only other spacecraft to have used ion propulsion to reach the asteroid belt. Dawn took 7.5 years to reach the dwarf planet Ceres. Along the way, 2 of its 4 reaction wheels failed. 2 out of 4. The mission survived by using its thrusters to compensate for what the wheels could no longer do, and it is now called a success. But read that sentence again. Half of a critical steering system failed in flight, and we call the mission a success because we got any data at all. That is not the language of a mature capability. That is the language of a fragile one. And here is the part that should bother you. Ion drives cannot recover from a lost year. There is no throttle up. There is no rescue burn. Every day of thrust already spent is a day that cannot be replayed. That's the propulsion. Now let's talk about what happens when the target itself turns out to be a lie. Because it might be. The image that has been sold to the public ever since the mission was first funded is of a giant metal sphere shining in the belt, an exposed iron world just waiting for a spacecraft to photograph it. That image is now looking increasingly wrong. Radar observations from the Arecibo Observatory, taken before the dish collapsed in December 2020, suggested Psyche has a density around 3.9 grams per cubic centimeter. Solid iron would be closer to 7.8. Nickel-iron mixtures fall in a similar range. What we are seeing is about half the density we would expect from a pure metal body. That is not a small discrepancy. That is a fundamental disagreement between the mission's founding hypothesis and the actual data. Hubble observations in the ultraviolet have detected signs of hydrated minerals on the surface, water-bearing rock, which should not be there at all if this is a naked planetary core. Thermal inertia measurements suggest a porous, rubble-like surface, not a shiny metallic ball. Put all of that together and you get an object that is probably not a solid core. It is probably a mixed body. Some metal, a lot of rock, possibly voids, possibly dust, possibly a gravitationally bound pile of rubble with metal veins running through it. Now do the math again on the trillion-dollar figure. That number assumed a pure iron, nickel, and platinum group metals composition. Cut the metal fraction by 80%, which is well within the range the newer data supports, and you have not mined a fortune. You have spent a fortune confirming a disappointment. Imagine flying to an island you were told was made of gold and discovering that it is mostly gravel with occasional flakes of gold running through it, and you cannot bring any of the gravel home. That is what this mission may actually find. And even if it does not, even if Psyche turns out to be exactly what the original hypothesis predicted, we still could not touch it in any economically meaningful way. Consider what it took Japan's Hayabusa 2 mission to return a sample from the asteroid Ryugu. 6 years. Some of the most sophisticated engineering on Earth. A near flawless mission. And the total mass returned was 5.4 grams. Not tons, not kilograms, grams. That is the current global state-of-the-art in asteroid sample return, and the trillion-dollar Comet story is asking you to scale that up by a factor of about 1 trillion, casually, as if it were a matter of building bigger machines. It is not. Which brings us to the wall that most of the coverage skips entirely. The scaling wall. The intuitive assumption most people have when they hear about asteroid mining is that we already have the technology and we just need to scale it up. Send a bigger ship, build a bigger drill, add more engines. That intuition is wrong at a level most people never get shown. The Psyche spacecraft weighs about 2,750 kilograms fully fueled. A meaningful mining operation, one that could actually extract, process, and return commercially significant amounts of metal, would need equipment measured in hundreds of tons at minimum. The delta V required to reach Psyche from low Earth orbit is roughly 5.5 kilometers per second. The delta V required to return mass from Psyche to Earth is another 5.5 kilometers per second. But now you are carrying cargo. And here is where the tyranny of the rocket equation starts to bite. Doubling the payload you bring home does not double the fuel you need. It can multiply it by 5, 10, or 20, depending on your engine efficiency. The exponential punishment of hauling mass back through gravity wells is not an engineering problem you optimize your way out of. It is a mathematical wall. To return even 1,000 tons of metal, which is a rounding error compared to Earth's annual iron production of about 2.6 billion tons, you would need a launch campaign larger than the entire Apollo program, sustained for decades. And even if you succeeded, the economics collapse under their own weight. The global platinum market moves about 200 tons per year. If you flooded that market with asteroid platinum, the price would collapse to near zero long before the first shipment paid for its own fuel. This is the reversal at the heart of the story. The trillion-dollar comet is worth trillions only if you do not sell it. The moment you actually mine and deliver, the market destroys the valuation. The dream eats itself. And this is before you factor in the truly hard costs. Refining metal in zero gravity, storing volatiles in vacuum, radiation shielding for the processing equipment, maintenance without a parts store, repair without a workshop. Every industrial assumption that makes mining on Earth economically viable, from cheap labor to abundant water, to breathable air, to gravity itself, disappears the moment you leave the planet. Space is not an industrial environment. It is an anti-industrial environment. So the machines do not scale. The economics do not scale. But maybe humans could go? Let's talk about what that would actually do to a body. Because the second you replace the robot with a person, the mission stops being difficult and becomes something categorically different. A 6-year round trip through the asteroid belt is not a longer version of a stay on the International Space Station. It is a different exposure entirely. Astronauts on the ISS lose about 1 to 1.5% of their bone density per month in the hips and spine. That is with 2 hours of daily resistance exercise, sophisticated equipment, and the protection of Earth's magnetosphere. Scott Kelly, after 340 days in orbit, came back with measurable changes in his gene expression, his cognition, his eye structure. Some of those changes never fully reversed, and that was still inside the magnetic field. The asteroid belt is not. Cosmic ray exposure in deep space is roughly 300 millisieverts per year, near or above NASA's own career radiation limit for a single trip. Not for a career of trips. For one. And that is only the background rate. It does not include a solar particle event, a burst of high-energy radiation from the sun that can, in the worst case, deliver a lethal dose in hours. Here is what the humanization looks like. The Earth's magnetosphere is not an abstraction. It is an invisible force field that every human who has ever lived has been standing inside. Every soldier, every farmer, every astronaut on the ISS, every child ever born, has lived their entire life under that shield. Leaving it is not space travel in the way we usually mean space travel. It is stepping outside the only shelter our species has ever had. Apollo crews were outside the magnetosphere for a maximum of about 12 days. A Psyche-class crewed mission would need to be outside it for years, with no way back inside until arrival home. Now stack that on top of the microgravity damage, bone loss, muscle atrophy, cardiovascular deconditioning, vision changes, immune system suppression, sleep disruption, cognitive slowing. Every one of those is documented in astronauts who spent a fraction of the time in orbit that a Psyche trip would demand. And every one of them accumulates. There is no plateau. There is no adaptation curve where the body eventually adjusts and stabilizes. The longer you stay, the deeper it goes. The reason NASA is sending a robot instead of a person is not caution in the way the word is usually meant. It is the physical fact that a human body cannot make this trip and come back the same, and on a bad radiation day, might not come back at all. That is the biology wall. And even if the body could somehow survive it, the mission itself couldn't. Here is why the logistics quietly break the entire concept. Because deep space mining is not a mission. It is a civilization-scale supply chain we do not have and cannot build in a single generation. Start with the simplest problem: communication. At closest approach, radio signals to Psyche take about 13 minutes one way. At maximum separation, over 40 minutes round trip. Real-time control is impossible. Every command sent from mission control is a bet placed on where the spacecraft will be by the time the command arrives. Communication delay is not slow internet. It is the astronaut equivalent of shouting into a canyon and waiting an hour to hear yourself back. Now layer in the deep space network, the global system of 3 antenna complexes at Goldstone in California, Madrid in Spain, and Canberra in Australia. That network is how every deep space mission phones home, and it is already oversubscribed. Voyager, Perseverance, the James Webb Space Telescope, Europa Clipper, dozens of active missions all compete for time on the same dishes. Psyche has to wait in line to talk to Earth. Add to that the refueling problem. There is no gas station in the asteroid belt. Every gram of xenon that Psyche's thrusters use had to be carried up from Earth's surface, through the atmosphere, through the gravity well, at the cost of enormous energy. If the spacecraft runs out, that is the end of the mission. There is no resupply mission waiting in the wings. There is no plan B. Add to that the recovery problem. If Psyche fails at any point in its journey, we do not send a rescue. We send condolences. Mars Climate Orbiter, back in 1999, was lost because 2 engineering teams used different unit systems, feet versus meters. That mission was 10 minutes away by radio. Psyche is 40. There is no forgiveness for that kind of mistake at this distance. And every single one of these logistical constraints scales up brutally the moment you try to imagine a crude version. Food, water, oxygen, medical care, psychological support, radiation shielding, redundant life support, all of it multiplied over years, all of it dependent on a supply chain that runs from Earth outward and cannot easily reverse. So the physics is brutal, the biology is impossible, the logistics do not close. Which raises the uncomfortable question: why does NASA keep saying this is going to work? The answer is not that NASA is lying. The answer is that NASA is phrasing carefully, and the phrasing is where the real story hides. Read the mission page like a prosecutor, and the softening becomes visible everywhere you look. Journey to a metal world is technically true. It quietly implies pure metal. Could help us understand planetary cause is a sentence in which the word could is doing enormous work. Mission cost of about $1.2 billion sounds like a headline number, but it excludes the launch, around 130 million ongoing operations, well over 100 million across the mission life, and the deep space network time, which is billed to the mission but often invisible in press releases. The real all-in cost is closer to $1.5 to $2 billion. And the trillion-dollar valuation, the number that dominated every single article ever written about this mission? It was never in an official NASA document, not once. It appeared in press interviews and public speaking engagements and thought experiments. It was allowed to spread because it kept the funding conversation warm. This is where fairness matters, so let me be very clear. I am not saying NASA is corrupt. I am not saying the scientists are dishonest. I am saying the communication has to be sellable, and sellable is not the same as accurate. The engineers are doing careful, meticulous work. The press cycle is doing something else entirely. Discovery program missions live or die on public excitement and congressional attention. Congress does not appropriate funding for confirming a rubble pile hypothesis. Congress appropriates funding for treasure. Every mission manager, every principal investigator, every public affairs officer knows the difference between what the mission is and what the mission has to be called in order to keep flying. The trillion-dollar headline was not deception, it was survival. And survival distorts truth every time, in every institution, whether the institution is a space agency, a pharmaceutical company, a national laboratory, or a university press office. That is not a NASA problem. That is a civilization problem. Watch how it works in real time. A scientist says the object could contain iron and platinum group metals worth an enormous theoretical sum if it were pure, and if you could return it, and if the markets absorbed it, and if the physics allowed it. The reporter cuts the ifs. The headline keeps the number. The tweet drops the context. The public sees treasure. And by the time anyone asks whether the treasure is real, the funding cycle is already over, and the spacecraft is already halfway to Mars. But even if you strip away the marketing entirely, there is still a bigger reason this mission matters. And it is not the one you would guess. Because Psyche is not important, because it might be rich. Psyche is important because it is a ceiling test. It is a measurement of how far our current civilization can actually reach. And the answer is, not nearly as far as we tell ourselves. Every major space agency on Earth has quietly shifted its language over the last decade, from colonize to presence, from settle to explore, from firm timeline to soft ambition. Mars in the 2030s has slipped to Mars in the 2040s. Now quietly, it has slipped to Mars someday. Artemis, the return to the moon, has been delayed repeatedly, and Artemis III, the crewed landing, is now no earlier than mid-2027, with a lander architecture that is still not fully flight-proven. We have not sent a human being beyond low Earth orbit since December 1972. 53 years. An entire generation has been born, grown up, and had children of their own without any human being leaving Earth's immediate neighborhood. The trillion-dollar comet story is really a mirror. It reflects a civilization that has learned to photograph the solar system beautifully and has quietly lost, or perhaps never really had, the ability to inhabit any of it. And this matters far beyond one mission, because so much of our public imagination about the future is built on the assumption that space is a solution. Climate breakdown. We will go to Mars. Resource depletion. We will mine asteroids. Population pressure. We will build orbital habitats. Every one of those ideas is standing on the same hollow ground as the trillion-dollar headline. If we cannot economically retrieve metal from an object we can already send a probe to, then every escape hatch, every backup planet ideology, every future in which humanity outruns its own problems by fleeing outward is standing on the same ground that just collapsed. Apollo was not just a triumph. It was also a peak we have not matched in over half a century. Psyche is the honest measurement of how far we have actually come since then, which is much further with cameras, no further with bodies. Think about what that gap really means. In 1969, human beings walked on another world. In 2026, our most ambitious deep space mission is a robot the size of a small van, whispering its way toward a rock we still cannot properly describe. That is not a failure of engineering. The engineering is astonishing. It is a failure of collective ambition, of political will, of the honest accounting we owe ourselves about what our species can actually do right now, in this century, with these bodies, on this budget. Every space enthusiast wants the future to be closer than it is. Every agency has incentives to soft pedal that gap. And every honest engineer, in private, will tell you the gap is wider than the press releases suggest. So what do we actually walk away with when this mission ends in 2031? Let's put every single piece on the table. Here is the case, consolidated. The valuation was a physics joke that became a marketing weapon. The target may not be metal. The propulsion cannot be replayed. The scaling laws forbid mining. The economics forbid return. The biology forbids humans. The logistics forbid rescue. The press releases forbid honesty. And the civilization itself right now in this decade forbids follow-through. Every single one of those claims is defensible from real data, real physics, real biology, and real institutional history. Not one of them requires a conspiracy. Not one of them requires bad actors or hidden villains. And that is what makes this warning so much harder to dismiss than a fake apocalypse. This is not a story about villains. It is a story about the physical universe being harder than our press releases. Let me be clear one final time about what I am not saying. I am not saying we should stop. I am not saying the mission is a waste. I am not saying the engineers should be blamed. I am not saying that space is pointless, or that dreaming of the stars is naive. I am saying that the story we are being told about this mission is softer than the story the mission itself is telling us. And the harder version, the one that lives inside the numbers rather than the headlines, is the one worth knowing. In August 2029, somewhere about 450 million kilometers from the Sun, a spacecraft roughly the mass of a small SUV will slide into orbit around a lump of ancient metal and rock. It will send back its first pictures, and in those pictures we will not see a fortune. We will see ourselves. Small, careful, reaching, and still very, very far from the future we like to promise ourselves. Missions like Psyche are how we learn what is really out there, and that alone is worth every dollar of the trip. But the trip is only worth taking honestly, not sold as a gold rush, not sold as salvation, not sold as an escape hatch, not sold as a future that any of us alive today will actually get to walk in. There is a version of this mission that deserves celebration on its own terms, a modest, careful, patient probe launched with real scientific humility, aimed at answering one hard question. That version is beautiful. That version is the one the engineers actually built. The version you were sold in the headlines was something else, and something less honest, and the gap between those two versions is where the warning lives. Watch the pictures when they come in 2029. Watch the data. Watch what the mission actually finds. But when the next $1 trillion headline flashes across your feed, whatever it is aimed at, remember this one. Because the catch was never the price. The catch was believing there was a price at all.